Section 4.3. This is the last section we're going to be looking at in Chapter 4. So, amortization and sinking funds. Okay, the first thing, amortization. So, we're going to be looking at primarily home mortgages and maybe car loans, things like that nature. And we're going to be amortizing them, okay? So, what does it mean to amortize a loan? That just means we're going to gradually write off the initial cost over a period of time, okay? We're going to make regular payments to pay off a loan. So the good news here is that this formula is the exact same formula we looked at in section 4.2, all right, for present value. So we don't need to learn any new formulas in this entire section. And what else can we use? Our calculator, which is going to be awesome, all right? There's a lot that goes into the amortization of a home mortgage, but we're going to try to keep it basic. Even though we will get into equity, we will talk about equity and things like that during class, okay? So, anywho, let's keep moving here. The next thing is a sinking fund. So we're not going to look at this, really as the strictest definition of a sinking fund. I mean, a sinking fund really is a fund established by an economic entity of some sort, all right? And what they would do is, a corporation maybe would set aside revenue over a period of time for maybe some future capital expense, or maybe for a repayment of some other type of long-term debt. We're going to just look at this from our perspective as a retirement fund. Okay, are we trying to determine how much money we'll need to put into an account to accumulate a specific sum of money? All right, so all we're doing here in section 4.3 is looking at solving now for R, which is what is the payment amount to amortize a loan, to pay off a loan? Or what should the payment amount be to accumulate a certain amount of money, S? And this is really what again? Future value. Future value is the same as S if we were to use the application in our calculator. So that's the big difference in section 4.3. We're now trying to determine the payment that we should make, regardless of what that payment is for. All right, so let's look at our first example. All right, so example number 1. Find the periodic payment R required to accumulate a sum of S dollars over T years with interest charged at the rate of R% per year compounded M times per year. So you can use the formula here on this, or you can use your calculator. So I will just go straight to the calculator for this one. All right. N is going to be what? N is going to be what? M times T. So that's 6 times 20. Okay. That's your N. It's always M times T. Interest rate is 4.5. So I'm going to enter in 4.5. Present value is, are we doing present value here? No. We're accumulating a sum of money. This is future value. So understand that. S is the same as FV, future value, okay? So present value will be what then? It'll be 0. We're not talking about present value. We're talking about perhaps a retirement fund of some sort, okay? The payment we're going to make, that's what we're trying to figure out, isn't it? Find the periodic payment R. So we're going to actually be solving for the payment here in this case. So we go down to future value. That's what this is, future value. We are trying to accumulate $100,000. So you enter in $100,000. And we're compounding at M times per year. So that's what? 6 times per year. So every other month. Okay, so that's 6. All right. And then all we got to do is move our cursor to what we're trying to solve for, which is the payment. And what do? What do you think? You guessed it, alpha, enter. And that's what the payment amount should be. Okay. case you didn't get that there, let me show you. Or in case you wanted to use the formula route, this is what you would have done. So you can pause that, take a look at it if you like. This is how you do it using the formula to solve for R, but you can see it gets kind of messy there. That's a lot to enter in your calculator. Or you can just use this application TVM solver. There's our answer. Okay, example number 2. This is similar to our first example, except now we're trying to figure out the payment required to amortize a loan. So this is going to be present value, okay? P goes with present value if we're looking at it in terms of our calculator, okay? All right, so let's just cut to the chase here. See if we can see if we can figure this out. All right, so N is still M times T. So we would have what? In this case, we'd have 12. Not there, you goofy. Oh, you. Golly. So anyway, 12 times 4 would be N. The interest rate would be 5. Put it in as straight 5 there. Present value, that's what's given to us. That's going to be 16,000. So really that'd be like the loan amount. Future value is going to be 0. And payments per year is going to be 12 in this particular example. So now you go to payment again, and that's what you're solving for. So you hit alpha, enter, and there you go. So this would be your monthly payment over a period of 4 years in order to amortize or pay off this loan amount of $16,000. All right, so your periodic payment R would be equal to what we just came up with there. So $368.47. Okay? Now, again, if you wanted to use the formula on this, you could do so. And this is the formula you would use. You're still going to get the same answer. This is what we just put in our calculator, though. This is my preferred method. Just don't make it any more complicated than it has to be. So you can pause this if you like, obviously, and take a look at it, especially if you're a formula person. Okay, this will be our last example we're going to look at in these very entertaining YouTube video lectures. And of course, we'll do probably 6 or 7 more examples during class. Okay, so example number 3, financial planning. Jessica wants to accumulate $10,000 by the end of 5 years in a special bank account, which she has opened for this purpose. To achieve this goal, Jessica plans to deposit a fixed sum of money into the account at the end of each month over the 5-year period. If the bank pays interest at the rate of 5% per year, compounded monthly, how much does she have to deposit each month into her account? Well, I'm going to use the calculator method, but the first thing I'm going to do is, well, think about what I'm solving for. So let's go ahead and set up the information. So this is what we have to enter into our calculator using the TVM solver application. So what's N going to be? Well, 5-year period. And I'm kind of doing this backwards, but it doesn't matter. It's commutative for multiplication. And she's making payments each month. Okay, so that's going to be 12. So this is T, this is M. N will be 60, whatever, or you can just enter it in like that. The percent is 5%, so that's just 5. Now, is this a present value or a future value problem? It's future value because she wants to accumulate a certain amount at the end of 5 years. So it's definitely a future value. And the future value amount is what I just looked at there, 10,000. So whatever one you're not solving for, that has to be a 0. Payment is actually what we're trying to solve for, okay? Whichever one we're not messing with is 0. What we're solving for is payment. And Jessica is making payments monthly, 12, and it's also compounded monthly. These will always be the same. Okay, so I put this information into my calculator. So payments, just put a 0 in there for now. That'll allow you to move your cursor in case that doesn't work. Okay, so you got to put something in, each one of these positions. Otherwise, your little cursor won't move. So we can do 5 times 12. Interest is 5. Present value is 0. Payment, that's what we're solving for. Future value, what we're trying to save, is $10,000. Everything else is correct. You go to payment. Here we go. Alpha. Enter. Answer. So you do get this negative $147 and what, 5 cents? So the answer would be, well, the meaning of this. So $147.05 per month. That would be what Jessica has to deposit every month in order to accumulate $10,000. Now, if interest was not applied here, let's see what would happen. If we just deposit this amount a month into some savings account with pretty much 0 interest, let's see how much we would have. So $147.05 times 12, okay? And then we're going to be doing this for 5 years, so times 5. So if interest was not a factor, Jessica would only save $8,823. So that just goes to show you the power of interest and that time value that interest has on money. Okay, again, I do hope you're doing well. I do hope you're staying safe. I do hope you're having fun. And I know you're loving this class. All right, rock and roll. See you guys in class, I hope, very soon. Bye-bye.